Glad we have Joe with us to give us a very informative tech talk about what we're doing here at Deere. And so, go through this presentation, and we welcome any questions at the end. So, won't hold it up anymore. Go ahead, Joe.
Yeah. So my name's Joe Hutchinson. I'm a robotics and autonomy engineer at John Deere, and it wasn't too long ago I was a student. I graduated from Penn State in May of 2017, and shortly after that I joined Deere. Moved down to North Carolina from Pittsburgh, and since then I've also started working on my master's at North Carolina State doing robotics and autonomy. So today I'm going to be talking about the cool stuff John Deere does in robotics, autonomy, and connectivity, and where the physical meets digital. So the slides today were brought to me by Alex Fossil, so shout out to him for that. So John Deere's higher purpose is to enable people to live better lives by serving those linked to the land. And it's a really lofty ambition because we're 7 billion people growing strong, and everyone needs food and nutrition. There are really like 3 key things that people need: food, water, and shelter. So providing one of them is a really important goal. Between 2010 and 2050, the food supply is expected to need to grow by 70%. This is a huge undertaking. And the problem comes with the 70% increase in food can only come from a 20% increase in land and farming area. So the rest of the 80% needs to come from increases in productivity. So that's really what John Deere is working on, is how can we get that 80% increase in efficiency out of a limited amount of land we have. And to meet this goal of feeding the world's population, John Deere's had to evolve multiple times over our history. It all started when John Deere himself created the first steel plow to till the American Midwest prairie without getting clogged. Then when the creation of the internal combustion engine, John Deere started making tractors that were more powerful. And when satellites and microprocessors became possible, we started with precision ag. Precision ag is when you minimize the amount of inputs to maximize the amount of outputs in a farm. So we're minimizing the amount of nutrition, water, and pesticides we need to apply while getting the most yield. The next evolution was connectivity. So with cloud technology, John Deere is able to connect our products to the cloud and to our customers so they can get an insight in their vehicles from their smartphones and their PCs. And finally, this is what I'm most personally excited about: automation. Automation makes farmers' jobs easier by automating simple tasks incrementally, while eventually getting the goal of fully autonomous tractors and other vehicles. So traditional agriculture and the change to precision agriculture is really where physical meets digital. In traditional agriculture, you're focused on making machines bigger, faster, and stronger. And then the change to precision agriculture is focused on getting higher productivity and profitability by making machines easier, smarter, and more precise. John Deere is focused on both sides of the equipment, both the machines and the services and agronomic information we provide to our customers, so that we can excel in both areas and be leaders in precision agriculture. And today's machines have more technology than ever before. So you might look at some tractors and think that they're just big hunks of metal, but really there's an insane amount of technology that goes into these things. There's, from front to back, it's lined with sensors, communications technology that help our products connect to the cloud, real-time data, which is extremely high fidelity, GPS, an operations center, which isn't a technology inside the vehicle, but rather it's a technology that lets our customers see into their fields and in their vehicles from their smartphones and from their computers. The last 180 years of agriculture have been relatively the same. Farmers have made decisions based on hundreds of data points that they've themselves witnessed on the farm. And whenever they want to go execute their tasks, they're doing manual action. And what they're changing, their inputs, the amount of water and the different types of passes they're doing, are all changed on a field-by-field basis. But once you move into precision ag, in the next 180 years, the way we do farming is going to look much different. Decisions are going to be made based on thousands of observations worldwide. So not only are farmers going to be making decisions based on the observations they have on their field, we're going to be taking data from the whole fleet of John Deere vehicles to make every product smarter. And the action that's going to be done isn't going to be done by a farmer doing it manually. These actions are all going to be automated. And instead of changing things on a field-by-field basis, we're able to change in how we care for each plant on a plant-by-plant basis so that each plant gets cared for in what they need in that moment. So what does this mean for agriculture? Where do we seem to be heading? Well, the key for the innovations in precision agriculture and where we're headed is all based on the technology improvements that happened over the past 10 or 20 years. Starting with the top left, sensors technology are huge in letting us see the world around us, letting vehicles be able to see what the environment that they're interacting in and to be able to execute the job. Sensors like LiDAR, ultrasonics, computer vision are all key sensors that help our vehicles. And we don't look at these different sensors in their own black boxes. We don't look at LiDAR and make some decisions based on that, and then look at ultrasonics and make some decisions based on that. You have to use sensor fusion to tie all these different sensing technologies together so that the machine gets a holistic view of the world around them. In the top right, you can see a microprocessor. This is really humankind's greatest accomplishment. Microprocessor has changed the way that humans do everything, from the way we communicate with each other, to the way we learn, to the way we entertain ourselves. And the microprocessor is also unlocking a lot of potential in agriculture. Moore's Law has treated us pretty well for a really long time, and we're starting to see some limitations there, but we're still enjoying the benefits of having an increase in performance, a steady increase. And then in the bottom left, we have the personal smartphone. Smartphones are another key innovation that help us have a window into the rest of the world, whether it be our friends, the news, or even like some things we're interested in. And then the final one, which is something I'm currently studying and I'm really excited about, is machine learning. Key advancements in technology and the amount of data we can collect are unlocking machine learning. So we've had the math solved for really 60 years on machine learning. So why is it just becoming a buzzword? And it's really not a buzzword anymore. Machine learning is unlocked because of these technology improvements and the amount of data we're able to collect. So we can train our machines based on many data points, and we're able to run these AI algorithms on modern processors. So believe it or not, this is the first volume autonomous product we ever released. And it's actually a product I worked on for the past year. So the John Deere E5 Series 2, which is what it is now, is an autonomous lawnmower, and it's really a good case study for why autonomy is important. People spend a lot of time mowing their lawn, and although some people enjoy doing it, many people just see it as a waste of time. Autonomy is a great technology because it frees time up for people to do things that are more important. So in the same way that this lawnmower frees up time from when people would be mowing their lawn, it also frees up farmers to be doing more important activities on their farm. We launched this product 10 years ago, but we launched it disconnected. So today, right now, we're working on getting this product connected and improved. And it's not hard to see how big the technology is in agriculture. Over the past 5 years, over $500 million has been invested in ag tech startups. So if startups are working on it, that means there's a lot of room for innovation here. In different areas such as analyzing satellite images, in-field monitoring, assessing crop soil and health, agricultural robots, and predictive analytics are all key areas we can see innovation happening. And we actually acquired one of these companies, Blue River Technologies. They're an agricultural robotics company that I'm going to talk about here shortly. So John Deere has an open digital ecosystem that lets our farming customers tailor their operation. Through Ops Center, we've connected over 100 tools from 2013 so that farmers can really tailor the information they need to see and the information they need to collect to execute on their farming operation. Having an open ecosystem is key.
What was the y-axis there?
The y-axis is the number of tools that are integrated in the Ops Center. So this is the pathway to automation. It all started off with a bunch of dumb machines, didn't have any intelligence built into them. And you needed multiple operators in order to get these machines to work. So the intermittent step is automating different tasks. So automating steering or unloading. And this is us slowly creating this autonomous technology and slowly building in intelligence into our products. And the final picture are fully autonomous machines that don't require much operator input. These machines are going to be able to go out and do their job without really a person on board or much input. And just to show you the work we've been doing over the past 10, 20 years on autonomy, we've been slowly building our technology portfolio out. It all started in 1999 with the acquisition of Navcom. In 2002, we created GreenStar and AutoTrack for assisted steering systems. This is our first shot at an automated steering system. In 2006, we created section control to reduce product overlap in the field. And this helps farmers reduce the amount of input, saving them money. In 2007, iTech Pro, which automatically guides tractors around end-of-road turns. So again, increasing the amount of autonomy that exists in the autonomous driving. In 2010, Starfire 3000 was created, which delivers 7-centimeter accuracy using GPS. And that's really unheard of in the GPS world. Most GPS technology has several meter accuracy, so to get 7-centimeter accuracy is really incredible. And it unlocks a lot of potential in what we can do in autonomous driving. In 2011, Machine Sync, which automates unloading on the go, was created. In 2014, we developed interactive combine adjustment. In 2016, AutoTrack and RowSense and Vision. So this is starting to create some computer vision technology that helps our products steer themselves. And in 2016, we released a new version of Starfire 6000 and SF3, which offers more precision and in-season repeatability. And in 2017, we released integrated combine adjustment, which guarantees consistent output of the harvesting process. So this is the work we've been doing on autonomy and robotics. So we're going to see what comes next. Here's a video showing one of our automated driving processes. So all the farmer needs to do is drive down and set up this machine. You're going to see the machine automatically align itself. And notice the Starfire on the top and the sensor on the implement there. So even though there's an operator in the seat, you can see the machine's using computer vision in order to sense where the rows of crop are so that it can drive itself. And this is where the real importance of autonomy is.
About how fast is it going?
You'll see in a second. So the machine's going 16 kilometers per hour Using automated driving, we're able to double the speed that our machines can go. And that's where the real value of autonomy is. It's increasing productivity while making the farmer's job easier. Machine learning is really unlocked with data. That's the key. Data and processing power. The processing power is here today. As long as you can collect enough data, you can do machine learning. And agriculture is a really prime example of where you can apply machine learning, because if you think about how many thousands of acres of farmland there are, even in one farm, there's so much information to be learned. Plant by plant, centimeter by centimeter, field by field. There's really an ocean of data that exists there. So with machine learning at the forefront, data is the fuel, not the exhaust. Every pass becomes a learning opportunity, and our equipment gets smarter over time. And this is because we can collect data while the machines are out on the field and continue to train our algorithms and deploy better machine learning models so that our machines can continue to get smarter, even if it's just the same vehicle. You don't need to buy a new tractor in order for it to get smarter. And better decisions mean better outcomes. So with machine learning in Ops Center, we can provide farmers with better decisions, leading them to better outcomes. And a grower has to make a lot of decisions over the course of a season, about 140 major decisions over a crop growing cycle. And when done right, this delivers real value. The key here is it's not just about the machinery, it's also about the agronomic, actionable information, the services, and the machine learning that makes this possible. So we can provide our farming customers with better decisions, leading them to a decrease in inputs, increase in yield, decrease costs, and improve resource management. And this is crucial for our customers, and it results in much better outcomes. Over the next few years, we're focusing on 3 key areas in Ops Center: plan work, monitor and control, and analyze and decide. Plan work is whenever we plan out the work that a piece of machinery does before it goes out on the field and executes it. Monitor and control is whenever the machine is out in the field actually executing. And analyze and decide is when the farmer can look at the data that was collected out in the farm, and he can analyze how the machine can do things differently. So the total customer solution, as you can see, isn't just about the vehicle. It's also about precision ag technology, dealer support and services, and connected software solutions that make our products stand out and make our customers more profitable and productive. And to show how serious John Deere is about technology, 2019 was our first year at CES, the Consumer Electronics Show. We came there with 2 key goals. We wanted to identify opportunities to bring new technology to agriculture for farm productivity, profitability, and sustainability. We also wanted to explain to the technology industry the reality of agriculture and how it impacts their everyday lives. The response to us going to CES was both energizing and really fantastic. And here's a little video of our vision of farming and what it could look like in the future.
The front should pass by midday. Based on drainage and when the rain stops, we should be able to start spraying by end of day.
On his way back.
He said he was checking on the boys.
Message from Walker Keane, John Deere dealer.
Hey Drew, update and check your combines remotely. All machines are optimized for harvest season.
Message to Walker. That's great. Thanks. Send.
Message sent.
Kate, did you see the latest? Looking at it now.
Dad's, worried.
With the solutions I see here, he'll be better. How are the boys?
They're working where we can't, and I'll be on it all night.
They'll get it done.
Your machines are set for projected yield and moisture. And we're also updating firmware on Harvester 3 tonight.
That's great. Hey, let's take a look at fields 5 and 6 tomorrow. You may want to make some changes there.
Yeah, sure thing. We'll check in tomorrow. Have a good one.
Thanks. You too, buddy. Go to field 5 and aggregate all. Mark?
Aggregate field 5. Recommendations. Phosphorus nitrogen application on sections 2, 8, and 27 with health predictions.
Go with solution 2, field 5.
Solution 2, field 5.
They look great. With the weather, prices are up by 10 cents at the elevator. You want to sell?
It's not bad.
Yep. Shall we?
Let's do it.
So as you can see, farming isn't just about the machines anymore. It's also about all the technology that comes along with it. And that's not just technology on the vehicle. You're also creating technology for the customers that runs on their phones and computers. All right, so here's some of the key takeaways. Farmers, believe it or not, are actually really have to be technology savvy. And they really like their business represented in a technological light. Automation is a journey, and we walk through some of the steps that John Deere's taken over the past 10, 20 years on working on automation. And it's a digital journey. Digital is inevitable. John Deere is starting to change. It used to be an iron first company, and now we're starting to think about things in terms of digital first. Human factors and user experience is never out of the algorithms. So even though technology can be kind of overwhelming, it can overpower the human experience, we're making sure we deliver technology in a way that we're still connecting with our customers. An extreme personalization, from general experience to personalized experience. We realize that every farm is different and the way every farmer runs his operation is different. So we need to make sure every farmer is allowed to have a personalized experience for the way they operate their farm. Does anyone have any questions?
What type of sensor technologies are you guys using to do all this stuff? Like, is it mainly radar as far as hardware?
So we use a lot of different technology. Kind of like anything you could think of, we're probably using. So a lot of the stuff they're using for self-driving, like LiDAR, ultrasonics, computer vision, and then that's just for perception. We have a lot of different sensors that can do other things as well.
I have 2 questions, but I'll let let someone else go before I ask my second. The first question is, most of these machines are going to be like, you need internet access or Wi-Fi or something, right? So what do you do in areas where that's not available or limited or like dead zones?
Yeah, so can't talk too much on the specifics of that because I'm not intimately familiar with this, but we do have some capabilities that even with a spotty internet connection, the machine can cache the data that it's collecting and then upload it whenever it gets a new connection. So we do have technology that can deal with spotty internet connections. And these machines don't have to be connected to the internet all the time. They can work if they're not connected. So that's not super important, but yeah, we do have stuff to handle that.
What about the digital factory and the factory automation? What is the company vision about that for later, just like how it is for machines?
Yeah, so automating in the factory is always important because, you know, the machine out in the field is only half the battle. We have to build the machines first. So I'm not too familiar with automation in the factory, but I know we work really hard to automate as much of that process as we can. We use programmable logic controllers and assembly lines that have automated parts. We have some factories that do entirely autonomous welding and some autonomous assembly. Yeah. Any other questions?
What are we doing realistically to assist those farmers who may not be as technologically savvy as others and may have some trouble getting used to the equipment and using it, even though it is autonomous? I'm sure there's going to have to be some type of setup or some type of interface with the user so that they get the job.
Yeah, so part of precision ag is actually trying to make our vehicles easier to use. So by integrating all this technology, we're trying to make it easier from the get-go. But a key point is, and a key differentiator for John Deere is we have a fantastic dealer support system. So our dealers work really intimately with our customers to help them get set up, keep going when the machine goes down, keep them up and going, and really help them through any problems they have. So that's how we do that.
Well, the tractors moving forward have the ability to update not just like firmware and software, but also with just the sensors and other things. I can imagine a farmer spending almost $1 million on a tractor and like wanting to update it as it goes. Is there going to be that sort of option available to them?
Yeah, I'm not too aware of what we offer there, to be honest. Yeah, so sorry, I can't really answer the question. Just for a little bit more background, even though this presentation was really on ag, I work in turf and utility. So my products that I work on are that autonomous robotic mower. I worked on that a little bit, and my main focus right now is an autonomous fairway mower for golf courses. So you have an operator that hops in the seat, presses some buttons on the display to get it to plan out its path for the day, where you should mow. You hit go, and then get off the mower, and it starts mowing fairways on its own. So even if you don't work, even at John Deere, if you don't work in agriculture, we can still share those super sophisticated, really cool technologies with other parts of the business. So for instance, for turf and utility, we're using the star fires that they created for agriculture.
So for the mower, does the dealer need to like program how the shape of the field is, or does the mower recognizes that on its own using the sensors that it has?
Yeah, so the small robotic mower for your lawn, what you do is you lay down a boundary wire similar to like a dog fence on where your yard is, and then it has sensing capabilities to be able to detect that wire whenever it's near it. So it will stay inside the boundaried off area. For the autonomous fairway mower, you have to take it out and actually drive it where the fairway is so that it can learn where the boundaries of the fairway are. And then once it's learned the fairway, you can just set it off and it can mow it itself. Any other questions? All right, well, thank you for coming. I hope you enjoyed the presentation.